number, this is for chapter 12, number 33 and 34. Really 33. Chapter 12, chi-squared. Okay, so the trick is, so the question is, again, if this has been the pattern of the entire spinor assignment where you use a random number table where things are totally random, which means there's no relationship between anything, which means the A0 is true, that's really the fundamental advantage of the spinor assignment. If it's random numbers, anything you pick can't be related to anything else. So the question is, how can you use the random number table to demonstrate the chi-squared? Well, in order to demonstrate the chi-squared, you have to have a couple of rows and a couple of columns, which means you have to have some variable that represents something here and something that represents it over here. So the variable that I'm going to pick, since there are 2 pages in the back of the book of random number tables, I'll pick the left page and the right page. So the variable will be page, left or right. And what's going to be the variable over here? Well, what's something which breaks up into 2 possibilities? And the answer is odd and even. So I'll put down this is odd, this is even. So the question is how many numbers to pick. So basically you're going to pick random numbers. You're going to pick, let's say, 5 numbers out of the back of the book. Here, 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 and here. You pick 5 numbers. And then you ask yourself, so there are 5 numbers. How many of those numbers are odd and how many are even? Of course, 0, 2, 4, 6, and 8 is even. 1, 3, 5, 7, 9 is odd. So say you pick, I'm just making up numbers now, but of course, yes. No, you're picking 5, just one group of 5 numbers. Okay, so like we've been doing very often. So let's say it turns out you would expect, well, how many expect, you would think most of the time you get 3 odd and 2 even, or 2 even and 3 odd, but you might get, for argument's sake, you may get 4 odd and 1 even, that's possible. It's going to happen to about 20% of the class. And then the other group will be what? Who knows? You might, on the other, you're picking 5 numbers out of this page. You can pick them in a row. You're picking 5 numbers out of this page, and this time you're going to get 3 odd and 2 even. So now we have the raw material to generate the chi-square. We have, this comes out to 7, of course. This comes out to 3. This comes out to 5. This comes out to 10. And if, of course, you should write down the hypotheses. A0, the 2 variables are independent, which of course is the truth. Now, do you think anybody in the class is going to pick, let's say, a 4 and a 1 and a 0 and a 5? Is that going to, yes, that happen to somebody probably. In that case, if you plug those numbers into the chi-square, do you think you're going to have to accept the A0 or reject the A0? If you got like a 4 and a 1 and a 0 and a 5. That person's going to be, now, does that mean the 2 variables are related? No, it just means it's happened. That was called a type 1 error. It just happened by luck. So what I want you to do right now in class is to write out the whole thing from beginning to end, write out the hypotheses, write out the, do the calculation. Don't use these numbers. Actually go to the random number table and pick random numbers. It should take you literally 3 seconds because you're just counting how many are odd and how many are even. Of classification are independent versus the H1, the 2 variables of classification are dependent. Those are the only 2 possibilities. It's the whole chapter. The data, the formula, the chi-squared formula, which you guys have been working out for the last few minutes, are FO minus FE squared over FE. Came out to, some of you came out to 0, some of you came out to 2.75, some of you might get a large number. We'll come out in a second what that number was. The third step is to go to the chi-square table with the alpha according to the spinor assignment of 0.10, not to be confused with 0.01. The degree of freedom is going to be r minus 1 times c minus 1, which is 2 minus 1 times 2 minus 1, which is 1 times 1 or 1, which means that the do not reject region will be bordered by, and I hope everybody check this out, 3.841. I'm sorry, not 3.841. What? Because now it's going to be a bigger, we're moving it over to the left, 2 point what? 706. I'm glad that seems to be the consensus. And finally, some of you are going to end up in the, most of you, according to the theory, 90% of you should end up in the accept region, because the truth of the matter is the A0 really is true here, and 90% of the time you should show that. But some of you, just by bad luck, are going to hopefully make a type 1 error of rejecting the A0, saying that they're dependent when they really truly are independent, because that gets random numbers, so they truly are independent. So now the question is, how many people ended up accepting the A0. Let's put it there. How many people scream out? We've got to count carefully. Accepting the A0. Again, if you really truly picked random numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So according to this. Now, by the way, if you're doing it together with somebody else, I hope you didn't raise your hand twice. So everybody who did it as a group, just raise your hand once. Anybody did it? So I have to subtract some of those? Okay, so 12. Anybody else got to be subtracted? Okay, so 12 independent done. How many people ended up rejecting A0? 1. Anybody else? So it's 1 out of 12 plus 1 equals 1 out of 13. Now, is that close to 10%? Well, 1 out of 10 is 10%, right? Now, we have 13 people doing it. Let's think about it, folks. In other words, did I come close to the theory? Did the theory, in other words, is it true that only about 10% of the class made a type 1 error? Now, think about it for a second. Is it close or perfect? It's perfect, because if we have 13 people doing that, I couldn't control. 13 people doing it. According to the theory, what percentage of the 13 people should end up rejecting A0? Just by making a type 1. What percentage of the class, according to the theory, should have rejected A0? 10%. How much is 10% of 13? 1.3 people. So how many people could I can't get 1.3 people, hopefully, right? So we got one person, which is about as close as you're going to get. So it really was perfect, the theory, in terms of describing the chance of a type 1 error.